Number 16 then from the 2018 Advanced Higher Maths 10-mark question here. Gaussian elimination is what you spot first of all, but it's actually all about planes, because that gives you the geometrical interpretation of the types of results you get when you apply Gaussian elimination to the solution of a system of equations. But anyway, first 4 marks for part A. Use that to find the value of A, so little a sneaking in there, such that the intersections of these 3 planes is a line. Now, by intersecting in a line, that means there's a redundancy. Any 2 planes meet in a line. If the third plane also goes through that line, it's not contributing anything. It must have been a combination of the other 2. But nevertheless, just start it off by writing out the augmented, I'm putting a straight line, sorry about that, matrix. Right, what can we do with that? Well, we'll transform it using elementary row operations. I want to get these 2 down to zeros first of all. I'm just going to abbreviate this. So that means row 3, that's row 2. Row 2 is going to become row 2 minus 3 lots of row 1. So leave row 1 alone because it was fine. Add a 1 at the top. That'll be 3, take away 3 is 0. Negative 5 but plus 6 is 1. Negative 2 minus 3 is negative 5. And 1 plus 12 is 13. Now this one, we'll need 7 of them. So row 3 is going to be amended to row 3 minus 7, no, plus 7 lots of row 1. Well, that makes that a 0 then, doesn't it? Then 11 minus 14, that's negative 3. A, well, that's just a plus 7. Negative 11 minus 28, that's a minus 39. Get a bit worried when you see numbers like that appearing, because the thing about this is you just don't know if you've made a mistake unless you end up with a nice answer. Then you think, I must have done it right. Well, there's a 3. Anyway, next bit, how do I get this down to a 0? Well, there's 1 in that row, so I'll change my row 3 by doing row 3 plus 3 lots of row 2. So that stays the same, that stays the same. That's still a 0. The whole point is that's going to go to 0. So if I'm putting on 3 of them, that's 15 away. That'll be a minus 8. And there, that came to 0. So there's your redundancy. You know you've got a redundancy when you get a row of zeros. So there's only 2 operating parts. That's like saying there's only actually 2 planes involved in this. So the solution will be a straight line. So, forgot what it said now. To find the value of A so that it's a line, so there's a redundancy. So I'll just go up here then. So redundancy, I can't even read that myself, means A minus 8 should equal 0. Because if it equaled anything else, you wouldn't have a redundancy, you'd have an inconsistency. And an inconsistency is equivalent to saying you've got planes that aren't intersecting at all. You could have these 2 intersecting, but if this third one came along and cut somewhere else, there's no solutions at all. Anyway, A equals 8. Part B. So what is this equation of the line of intersection when A takes this value? Well, if A takes this value, that's a 0 at the bottom. You've got a redundancy, which means effectively Z can be anything. So you just let Z be anything. You could even call it Z, but usually you go for something like lambda. So step back up. This second line says y, take away 5 of those Z, so minus 5 lambda equals 13. Well, there you go. Y equals 13 plus 5 lambda. Step back up to this line. X minus 2 of those plus 1 of those, which is plus a lambda, equals negative 4. A bit more messing about here. That's minus 26 minus 10 plus 1 is minus 4. So that means X is going to equal, take that across, and that's 22. That's negative 9 plus 9 lambda. So there it's there. There's the parametric equation. Unless you want to put them in order. Not leaving myself much room to do that. Could I squeeze it down here? X equals 2 plus 9 lambda. Y equals 13 plus 5 lambda. Z equals lambda. Because I didn't actually say find the equation of the line in parametric form. So if you wanted, you could put them back into a vector form, because keeping it this way, everything's nice and neat. Position vector, initial point, lambda times direction vector. And why not, while I'm at it, change that back to 22. 26 onto that, it's 22. Part C. This new plane, pi4, has been introduced, and it says, what's the angle between this new plane and the first plane, for 3 marks? Well, the angle between the planes are just the angle between their normals. So, find the normals of them. So what's the normal of plane 1? Well, you just extract it from its equation there. That'll be 1, negative 2, 1. The normal for plane 3, no, that's plane 4 they want, is negative 9, 15, 6. So, what's the angle between these normals? Well, you just work out all the parts, don't you? N1 dot N4. Work that out first of all, because if that comes to 0, that's the end of the question. That means they're perpendicular. So you've got 1 times negative 9 is negative 9, minus 2 times 15 is 30, plus a 6. So that comes to negative 33. Well, they're not perpendicular, so we just have to go through the whole thing then. Right, next then, what are their magnitudes? Magnitude of this one is 1 plus 4 plus 1, so that's root 6. Magnitude of this one is the square root of, this is a bit worse, 81 plus 225 plus 36. Use your calculator, but that's 306, so 342. Then we can just say this. So the angle between the vectors is going to be negative 33 over root 6 root 342. Now you're just using your calculator. That negative means you're going to get an obtuse angle. You can sort that out to get the acute one if you want it by just taking the absolute value. And when you press the buttons, you get 43.239 and so on. So we'll just say this then. So the angle is going to be 43.2 degrees. Describe the geometric relationship between plane 2 and plane 4, justifying your answer. So what's between these two? Well, look, those numbers are the same. Well, they're not the same, there's 3 times them, but this isn't. So that means these planes are parallel, but since those two numbers don't come to the same thing, they're not parallel and actually coincident. They're actually parallel and separate. You have to justify that. Right, okay, so N2, because I've already got N4, N2 is 3, negative 5, negative 2. N4, the normal to 4, is actually negative 3 times that. No, is negative 3 times it. So it's negative 3 N2. That means that plane 4 is parallel to plane 2. But are they parallel or are they actually the same plane? You'll have to justify this part as well. Since 20 is not equal to negative 3 times 1, that means that pi 4 and pi 2 are separate.